Yes, dear student, now there is a question here. Early model of atom consider atom to be neutral and having plus Ze charge in nucleus. Ze point charge of nucleus surrounded by negative charge plus minus Ze. Atom as a whole neutral. So he asked what is the electric at point P outside at on the surface and at any point inside here. अगर हम यहाँ पॉइंट P यहाँ लें तो where will be what is the electric field? The solution is very clear. For any point outside the atom, E into 4 pi r square surface integral of electric field of Gaussian surface here is equal to 0. Why? Because no net charge inside. Sphere atom as a whole is neutral. So at any point outside E equal to 0. At surface again E equal to 0 because Gaussian surface does not include any charge inside. Is that clear? Now if I find P inside here, that distance r is this. Capital R the radius of atom. Then if we consider Gaussian surface of radius r, if r less than capital R, so E into 4 pi r square, it will come out surface integral of the surface sphere. It is a sphere here. Equal to total charge. How much is the charge? Charge of nucleus Ze plus or minus Ze charge distributed over the whole 4 upon 3 pi r cube. No, charge in this Gaussian surface minus Ze upon 4 upon 3 pi r cube. What is this? It has become volume charge density. Volume charge density multiplied by volume. How much is volume? 4 by 3 pi r cube. So we get it minus Ze r cube upon capital R cube. So I will write here minus Ze r cube upon capital R cube upon epsilon 0. Surface integral is total charge inside divided by epsilon 0. Or you can write Ze common upon epsilon 0 1 minus r cube upon capital R cube. E into 4 pi r square or E equal to Ze upon 4 pi epsilon 0. This r square is there. I will write here 1 minus r cube upon capital R cube. Or we can write it as E equal to Ze upon 4 pi epsilon 0 1 upon r square minus r upon r cube. For any point inside. If we come at center, r becomes 0. So this is 0. So field is 0 because that include no charge. Whole charge will be outside. Z nucleus has been taken and point charge. Point charge in no dimensions. So this is one example based on spherical charge distribution. Now there is another good question for you here, especially who are appearing different competitive exam and opted physics as subject. Actually, there are different exams for getting good job like CGL, etc. Dear student, you know you are much smarter than me in YouTube. You please subscribe my channel, and I hope you can share the videos among your friends. Please, it will help the public. I am here just to tell so many facts which are not taught in the classes. Now, what is the question? If we have a spherical charge distribution like this, having charge density rho coulomb per meter cube, then it is radius r1. This radius is r1. If we cut a cavity here of radius r2 at point here, this is center O, this center of cavity is P, and distance A. This is R2 radius. Radius of the cavity R2. Now, and here A is equal to R1 minus R2. A is equal to R1 minus, I think diagram is clear. So you are asked electric field at point A, which is inside cavity. ये point A inside cavity है यहाँ पर. So what is the electric field at this point? This is cavity here. Means the charge has been taken out. It has uniform distribution of charge. Suppose positive charge, whose charge density is sigma coulomb per meter square, per meter cube. Sorry. So we know electric field at any point inside E is equal to vector E is equal to rho into R vector upon 3 epsilon 0. We know this thing. Now this is position vector A with respect to O. This is suppose this is vector R. Here, position vector R, and it is B. OA, vector OA is equal to vector B, vector OP is equal to vector A, and PA, vector PA is equal to B, vector OA is equal to vector R. Please listen very carefully. Point P is inside the cavity. P is the center of cavity. O is the center of charge distribution. So we know electric field at any point. We will make use of this thing. So field due to original distribution at P, let it be E1. It is equal to rho upon 3 epsilon 0 R due to whole sphere. Originally, when there was no cavity. When there was no cavity. If it is a sphere of radius R, away, तो ये होगा. But now, if we think the field of this sphere having same charge density, then this E2 will be rho upon 3 epsilon 0 B vector. But since cavity has no charge, so actual field inside cavity will be vector E1 minus E2. Why minus? because field due to this charge present in cavity has been withdrawn, charge has been drawn. So no charge inside that field has been decreased. So we put 1 upon 3 epsilon 0 r minus b. Vector A plus vector B in figure. In figure, vector A plus vector B equal to vector R, and hence vector A equal to vector R minus vector B. So putting here we get E equal to rho upon 3 epsilon 0 A vector A. This question has been asked many times in different exams like IIT, etc. So what does this indicate? That value of by radius A, तो ये distance fix है, चाहे point यहाँ, other point here or here or here. Magnitude of electric field inside cavity is the same, but direction depend on vector A. Direction of electric field inside will depend on the position vector. अगर ये कैविटी यहाँ होगी तो फिर डायरेक्शन नहीं होगी. अगर यहाँ direction is point is along vector A, indicate this way. So please try such questions from different exam, competitive exam, and I told you that electric field due to a sphere, if I take point P here and there was no gravity, then I told you this E here will be rho upon 3 epsilon 0 vector R upon R square outside. In my last video it is there. You remember this way. In classes this topic is not taught. I try to teach, but my colleagues start murmuring and say, sir, you are creating trouble for us. So please subscribe my video, share my video, and work hard for your bright future.